Hi guys, in my previous video we have completed the whole ring chain structures. We completed the saturated structure, that is alkanes. We have seen how the compounds are formed in alkanes, and then we even completed with alkenes and then even with alkynes. So the second set of compounds or the things which we are going to learn is the ring structures. Means till now the compounds were formed in a straight chain manner in this manner. The ring means, the name itself says, they would be in this manner. There would be, here if you see there is no closing, but here there is a closing. It would be like this, or it would be even be like this, and it depends. So cyclo means they would be in a cycle manner, or there would be a closure, or there would be a closure for the carbon atoms. Now the ring chain structures are again of two types: cycloalkanes, cycloalkenes, and cycloalkynes. So here also we have again cycloalkanes, cycloalkenes, and then cycloalkynes. Now here for alkene and alkyne we started the series with n is equals to 2, but here the name itself says it's a ring. So is the ring possible with n is equals to 1? Means only one carbon atom. Can we draw a ring for one carbon atom? We cannot draw a ring for carbon atom. For 2, see, nowhere it's forming a ring, it's a straight. But if you see for 3 can be arranged in this manner, or it can even be arranged in this manner. C. In this manner is also possible. But for n is equals to 1, the number of carbons 1 and 2, the value of the getting the ring chains is difficult for n is equals to 1 and n is equals to 2. So this says that these cyclos or the ring chain structures start with n is equals to 3. They start with n is equals to 3. 3 means the word root would be probe. And the name would be differing, the suffix, and for the ring structures we'll have prefix as well as suffix. The prefix would always be same for the ring structures, that is cyclo. The suffix would be changing. If we are drawing cycloalkanes, then the suffix would be a. The compound would be cyclopropane. And then if you see cycloalkenes, again same, the prefix would be cyclo, and it is starting with n is equals to 3, so the word root would be prop, and the suffix is ene, so the name would be cyclopropene. And then if you see for alkynes, it would be having the same prefix and the same word root if n is equals to 3, and here this suffix would be changed. Cyclopropane, this is cyclopropane, and cyclopropyne. Now let us get into detail for drawing each of the members' structural formula, and then the condensed formula, and then the namings we will do for each and every specific ring structure. Now as I already said, the value of n for cycloalkanes would be starting with n is equals to 3. If they ask why is n is equals to 1 and n is equals to 2 is not possible with cycloalkanes, we can say that with 1 and 2 carbon atoms we cannot form a cycle, or we cannot form a ring structure. So it starts with a 3. The structure would be 3 carbon atoms in cycle manner, and then the arrangement of hydrogen atoms here. C in cycle manner. The general formula of cycloalkanes, let us derive it now from here. Now this has got 1, 2, means more 2 bonds are required for this carbon atom. For this, if you see 1, 2, 3, 4, and then for if you see 1, 2. So each carbon is having 2 bonds. It requires additionally 2 bonds. So we got 2 bonds. What is the compound? C3H6. This is the name of the compound because 3 C's, then 1, 2, 3, 4, 5, 6, 6. Let us give the formula at the last after writing for 3 and 4. Then the condensed form would be CH2, CH2, CH2. This is the condensed form. The electron dot structure for the carbon here, if you see here 1, here 1. Okay, and for this carbon atom here 1, here 1. And for this carbon atom here 1, here 1. Here if you see this carbon is having only 2, so more 2 I am adding here. And for this also I am adding here 1, here 1, here 1, here 1. And then putting the hydrogen, because if you see from the structural formula, hydrogen, if there is one bond between carbon and hydrogen, it should have 2 electrons. One is from carbon, one is from hydrogen. So this is from carbon, this is from hydrogen. This bond is satisfied. This bond is satisfied. This bond is satisfied. Then even this is satisfied. This is satisfied. And then this is satisfied. 2 for each hydrogen atom. Now let us start from this carbon atom to draw the circles for carbon. 1, 2, 3, 4, 5, 6, 7, 8. Like this. Don't include this, we are only bothered about these 8. Now 1, 2, 3, 4, 5, 6, 7 we got. For this carbon if you see 1, 2, 3, 4, 5, 6, 7, 8. Like this. 1, 2, 3, 4, 5, 6, 7, 8. For this 1, 2, 3, 4, 5, 6, 7, 8. Like this. It's a bit difficult to understand, but if we practice, it's very easy to draw the electronic dot structure. So now if you see for this carbon 1, 2, 3, 4, 5, 6, 7, 8, 8 are done. For this 1, 2, 3, 4, 5, 6, 7, 8 done. For this 1, 2, 3, 4, 5, 6, 7, 8 done. So we got hydrogen is having 2 electrons and then carbon is having 8 electrons. This is done. Now the IUPAC name, as it's a cycle structure. Here the prefix is cyclo. So cyclo, and the word root, if N is 3 then the word root would be pro, and the suffix is A. The compound is cyclopropane. What's the compound? Cyclopropane is the compound. Now let us see for N is equals to 3. If N is equals to 3, N is equals to 4, if N is equals to 4. Remember, if the number of carbon atoms says the shape to form. If it is having 3 carbon atoms, as I can say in mathematics, a shape which has 3 sides, it's a triangle. So we can remember like this: if N is equals to 3, then the carbon arrangement should be like this. So at each vertice there should be 1 carbon atom. This type of notation is known as bonded line notation. This type of notation is now called as bonded line notation. So if N is equals to 3 means 3 sides triangle, 4 sides quadrilateral, or we can simply say rectangle, 5 sides pentagon, 6 sides hexagon, 7 sides septagon, like this. Now if N is equals to 4, then the arrangement should be in a rectangle form. So it should be in a rectangle form. So at each terminal there should be 1, at each vertex there should be 1 carbon atom. So 1, 2, 3, 4. Done. Now hydrogens 1, 2, 3, 4. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8. So if there are 4 carbon atoms, then in cycloalkane the number of hydrogens are 8. Number of hydrogens are 8. Now the condensed form CH2, 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 and then this. Now the electron structure will be again the same. You will be representing the carbons like this, and then for this bond, one here, one here, one here, one here. I mean, one for this, one for this, one for this, one for this, and then one for this. So again here one, 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 here one. So each carbon is having 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then one hydrogen here, one hydrogen here, one hydrogen here, one here, and yeah, here one, here one, here one, here one. This is the electron dot structure for n is equals to 4. 1, 2, 3, 4, 5, 6, 7, 8. We got 8. And now for carbon 1, 2, 3, 4, 5, 6, 7, 8. Like this. For this 1, 2, 3, 4, 5, 6, 7, 8. For this 1, 2, 3, 4, 5, 6, 7, 8. For this 1, 2, 3, 4, 5, 6, 7, 8. So this is the electronic dot structure. I know it's so clumsy here on my board, but this is the electronic dot structure for n is equals to 4. And the name, the prefix would be same, cyclo. Then if word root is 4, it is but, and the suffix would be al again. So the compound name would be cyclobutane. This is the name of the compound. Now from the structural formula, try to get out the general formula for cycloalkanes. If C is 3, H is 6. If C is 4, H is 8. And now for C5, let us see. I am drawing the bonded line notation. 5 means it should have pentagon, right? So at each terminal we are having one hydrogen, and then for each carbon again 2 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if it is C5, then the hydrogen atoms are 10. Then for 6 it would be 12. Means it's the formula we can bring out is if C is N, then H would be 2 times N. Is the formula working out? If N is 3, then the H is 2 times of 3, 6. We are getting C3H6, right? And if C is 4, C4 and H is 2 times of N, means 2 times of 4. 2 4s are 8 we are getting. Now for cyclopentane, you see C5, N is 5, C5 and H 2 times 5, 10. So the general formula of cycloalkanes is CnH2n. So no need of remembering the formulas, the general formula in ring structure, and because we can note, we can just identify, and even the same we will do the identification of the general formula for cycloalkenes and cycloalkynes. Only we have remembered 3 formulas in alkanes, alkene, alkynes. From here we are not remembering the formulas. We will be just drawing 2-3 compounds. The bonded line notation is more than enough to get the formula. So from that thing we will get the formula. So we are reducing our burden, right? Remembering the formulas, instead of remembering we are deriving the formulas. Fine. So I hope you have understood. I have given a brief explanation about all the 3 ring structures: cycloalkanes, cycloalkenes, cycloalkynes, and then I have explained about cycloalkanes. So I hope you have understood today's video, and in my next video we will be doing with cycloalkenes. Thank you.